Welcome back, everyone. Today I'm diving deep into vector semantics in natural language processing, or NLP for short. So, what is vector semantics? Imagine you have a bunch of words and you want to understand how they relate to each other. Words can be represented as vectors in high-dimensional space, allowing us to capture their meanings numerically. This is a key concept in NLP. Let's break it down. At the core, vector semantics is all about representing words as points in space. Each word is a vector, and vectors close to each other in this high-dimensional space represent words with similar meanings. Think of it like a map, but instead of cities, we have words. One popular method is Word2Vec, developed by Google. Word2Vec takes a large corpus of text and uses neural networks to learn vector representations of words. The closer the vectors, the more similar the words. For example, king and queen are closer in this space, whereas king and apple are farther apart. But how is this useful in real life? Let's start with search engines. When you type a query like best places to eat in Paris, the search engine uses vector semantics to understand the meaning behind each word and fetch relevant results. It doesn't just look for pages with the exact words, but retrieves pages with similar meanings, enhancing the search experience. Another example is translation services like Google Translate. When translating good morning from English to Spanish, the system uses vector semantics to understand the context and find the equivalent buenos dias. This makes translations more accurate and natural. In customer service, chatbots use vector semantics to understand user queries better. If you ask, "I need help with my order," the chatbot can recognize that order and purchase are related, allowing it to provide relevant assistance quickly. Here's a fascinating real-life case. In 2016, researchers used vector semantics to analyze Twitter data during the Brexit referendum. They identified groups of similar words and phrases, gaining insights into public sentiment and key topics of discussion. This helped in understanding the public's mood and predicting outcomes. Now, let's talk about some challenges. One challenge is the curse of dimensionality. High-dimensional spaces can be computationally expensive and complex. Another issue is bias. If the training data contains biased texts, the resulting vectors can reflect those biases, which can be problematic in applications like hiring algorithms. But the field is evolving rapidly. Researchers are developing new techniques like BERT and GPT, which push the boundaries of what's possible with vector semantics. These models understand context better than ever before, leading to advances in everything from text generation to sentiment analysis. To wrap it up, vector semantics is a cornerstone of modern NLP, transforming how machines understand and process human language. From search engines to chatbots, its applications are vast and impactful. If you found this deep dive into vector semantics enlightening, don't forget to like, share, and subscribe. And as always, if you have any questions or topics you want me to cover, leave them in the comments below. Thanks for watching, and see you in the next video.